can wait around a little bit while people start to trickle in.
Yep. Is the full title Play with Your Code, Exploratory Coding in Pico 8?
That's the title.
Oh, let me
Oh.
announce it on Discord. Or actually,
Very good.
We've got some people coming in. We'll get started in just a few minutes.
Yep.
Some more people come in.
Hello, everybody, and welcome to the thing.
This is the thing. This is the place to be on Wednesday night.
that is so
It
true.
sure is.
Yeah.
Alright, what do you think? Do we have a quorum in the chat?
Should we get started?
Over to you, Josiah. Let's get going.
Okay, let's get the show on the road. Hi, thanks for joining our stream. I'm Josiah. I'm one of the organizers for Let's Games Tokyo, a bilingual site which runs Global Game Jam every year in Tokyo. こんにちは。参加いただいてありがとうございます。ジョサヤと申します。Let's Games Tokyo のオーガナイザーをしています。毎年、グローバルゲームジャムと呼ばれているゲーム開発ハッカソンのイベントは、世界中において行っています。Let's Games Tokyo は東京のグローバルゲームジャムの開催場所です。So to talk a little bit about Let's Games Tokyo, we really believe in sharing knowledge and helping each other, no matter what our skill level is. And one of the perks about participating in our global game jam site is that we have mentors available to help you while you're on site. And also, those mentors every year, we ask them to do these pre game jam streams, where we do essentially like learning sessions on specialty topics like new game engines or importing assets into your favorite engine, or how do you plan your game during the game jam. And also, our mentors are on site during the game jam, obviously, as well, so they're there and available for you to ask questions, bounce ideas off of, and get feedback. I want to say thank you to all of our mentors and volunteers who are giving their time to us to help us make this event possible. では、ゲームジャムは、経験に関わらず知識を共有してお互いに助け合うことが重要だと考えています。Let's Games Tokyo の特典としてゲームジャムの参加者をサポートするためメンターがいます。メンターはゲームジャムの経験があり、ゲーム開発が詳しいです。毎年その知識を共有するため学習セッションをしています。生配信で新しいゲームエンジン、アセットのインポートする方法、計画の立て方などについて説明しています。そして何より、イベント会場で直接メンターに質問することもできます。メンターたちにサポートしていただいて心から感謝していたします。This year, our mentors are Eric, Phil, Matt, Jaren. I'm sorry. Can you help me with this name?
Yeah.
Yeah.
That's correct.
Yeah. And me. I'm actually not doing a mentor session this year, but I will be available. I'll be in person at the site. And this is our final mentor session actually. Yesterday, I believe we had who presented yesterday? CJ?
Philippe.
Was it Philippe? Okay,
Yeah, Phil
Philippe
presented
presented yesterday. And this is our final session today. Matt's going to be presenting a presentation on Pico 8 called "Play with Your Code: Exploratory Coding in Pico 8." 日本語で。昨日、one second, sorry. The name of Philippe's session was.
Unity to Godot.
Oh, you need to go do. Oh, I see.
Yes.
昨日
Pitfalls and I don't remember the subtitle. Sorry.
昨日フィリップさんにUnity to GodotエンジンからUnity エンジンから Godot エンジンへの、移植についてのセッションを、話して、今日はマットさんに、ピコ8、ピコ8について、Play with your code で Exploratory Coding、ピコ8での遊びみたいな感じで説明していただきます。質問は生配信中でもいつでも大丈夫です。遠慮せず聞いてください。Before I pass it over to Matt, I want to make a small request. This is a volunteer run organization, and we're relying on benefit and support from participants in the game jam and people who are supporting us in order to provide these fun activities and also to provide like snacks and amenities during the game jam itself. So if you could please consider giving anything at all, 500 yen or 1,000 or something. We have a Ko-fi at Global Game Jam Tokyo to support us. So we would really appreciate that. 日本語 Let's Games Tokyo はボランティア運用されており、イベントのおやつや飲み物など自己負担になっています。もしよければ、GGJ 東京のコーファイのリンクを通して支援をしていただければ嬉しいです。So now I'd like to pass it over to Matt. Please give him a round of applause. それでは、マットに渡したいと思いますので、拍手をお願いします。Over to you, Matt.
All right. Thanks, Josiah. So without further ado, I would like to present Play with Your Code. じゃあ Play with Your Code へようこそ。これからプレゼンするのはずっと英語になります。ですが、後で、翻訳されたスクリプトとかスライドをシェアする予定です。I'm going to be presenting the rest of this in English. I'll make the slides and the script available later in both English and in Japanese. So, today I want to talk about exploratory coding and this exploratory mindset. Before I get there, let me introduce myself properly. My name is Matt. I'm Mabby's on Discord. I've been doing Global Game Jam for a good at least 10 years now, I think. And I've been a mentor and organizer with GGJ Tokyo for the last couple of years. I also make games as a hobby with my partner CJ. We put out a game called Terra Nova that I'm quite proud of, and I would love if you check it out later. What I want to talk about today is some mindsets that you can try out while you're jamming, and I want to talk about choosing good tools for your global game jam. I'll share a few tips, and the second half of this talk is all going to be live coding. I've got a few demos that I can fall back on if the live coding doesn't go well. I'll at least Julia Childs show you the version I baked earlier. But I think it'll be real fun to do some of that live on stream. So let's start with the theory. Here are two creative mindsets. They're not the only ones that exist, and maybe neither one in their purest form really exists, but I think understanding the difference is a good place to start for deciding how you're going to approach the game jam. So with the goal-directed creative strategy, what you usually do is make all your design decisions up front. You come up with a plan, and the rest is, big scare quotes, just the details, just making the actual assets in the actual game. Along the way, you will probably encounter some obstacles, and you'll need to solve those problems, work to overcome them. But this can be a good strategy for working on a team. If you have this shared goal that everybody has, it really helps for aligning the work, making it so that you can distribute work amongst people, and still recombine it into something coherent later. You're probably familiar with this kind of creative mindset from your work, especially if you work in a creative field or in a product company. On the other hand, I want to really encourage you to approach Global Game Jam with an exploratory mindset. And this is a lot different. Instead of planning things up front, this is about making decisions along the way. It's kind of feel-based. It's going with what feels good. One of the merits of this strategy, one of the things I really like about it, is that when you encounter obstacles, they're not problems that you need to solve necessarily. It's just information. It can even be a source of inspiration. It can be like, this thing is hard, so I'm just going to not do it, and I'm going to go off in a different direction and see if the things that are fun and easy give me better results. And overall, I think this is a really fun way to approach creative endeavors. If you're going to have this playful mindset, I think it helps to have the right toys. Does everyone know what these are? Answer in the chat. You know what these are. They're Legos. I hope that all of you have had a chance to play with Legos at some point. I think they're a really fun toy, and I think there are a few things they do particularly well. Legos are very modular. They're like the poster child for modularity. People don't even say, let's make something modular. They'll say, let's make this thing like Legos. And that's what they mean. They mean a thing that you can take apart and recombine in cool ways. I think one of the other things that Legos do really well is that they're the right size. I think if you get an off-the-shelf Lego set, it's got a few hundred pieces in it, maybe. And that's not too few and it's not too many. It's enough that you can still recombine them in interesting ways if you don't want to just follow the instructions that come with it and make what's on the box. But it's also not throwing millions of pieces at you and you get overwhelmed and can't deal, right? I think the design of Legos is such that each piece is really this right size to contribute to a bigger whole. And also along that lines, I think Legos have a really great level of abstraction to them. What I mean by that is that a lot of Lego bricks are just rectangle, and that's fine too. But there are also pieces like, if you all can see my cursor, I'm not sure, this gray one that's in the middle here. I think that's a really cool piece. It kind of reminds me of like a fin that you'd put on a rocket. Or maybe it could be part of a hydrofoil on a boat. It could be an architectural feature. You could make a cool retro drive-through diner or something like that. And I think that's kind of cool that one piece can be all those different things. That it's something enough that it kind of evokes some of these thoughts. I don't have to come up with all of the ideas by myself. I can kind of have this conversation with the Legos themselves. What do you want to be? And in that way, you can explore while you're building with them. On the other hand, does anyone know what these are? Answers in the chat. And I will give you a hint. This is not uncooked rice. Okome janai. So these are called plastic nurdles. This is the way that plastic... Yeah, Phil's got it. This is the way that plastic is usually shipped. Not always, but... And hopefully less and less these days, because plastic in this form can often become an environmental hazard. But these, I think, are very versatile. You can... If you have a factory that makes stuff, mass produce a lot of cool things out of them. You can extrude them and injection mold them and make all of the little plastic things that you buy at Daiso or the 100 yen store. But as a toy, they're not anything. They're just beanbag filler or something. They're very inert. They're very uninspiring. You're not going to look at a bunch of plastic nurdles and think, wow, I could make a cool spaceship out of those. You probably could, but I don't think that's the first thought that you'd have. I bring up this analogy because I feel like the same can be said of some of the tools that we use to make games. And that's part of why I'm choosing Pico 8 to run this talk. I think it has some really carefully designed constraints, and I think it does a lot of things that evoke a mood, evoke what kind of game it wants to be made into. I think having those constraints can be a really good thing for a game jam. It can, for example, if you decide, I'm going to make a GB Studio game, then you can make a thing that you can run on a Game Boy. You will be limited by your color palette. You probably will have to use 4 colors for everything, 4 shades of gray. But that means you don't have to spend your limited time during your game jam trying to make those creative decisions yourself. You don't have to pick a color palette, and you can spend that time doing all of the other things that go into making a game. So that's my tip. Game jam tip number 1. Embrace constraints. If you can let your materials dictate, or if you can get design decisions for free out of them, do it. Game jam tip number 2. When life gives you nurdles, melt them down and make Legos. I think, especially with some of the more capable game engines like Unity or Unreal, these have a lot of flexibility. They have a lot of power. You can make a lot of different kinds of games out of them. And in some ways, I think that makes them a handful of plastic nurdles. You don't really know what to do with them or where to start. And it can mean they're not very fun to play with. They're not fun to tinker in. So I think if you're going to use one of those engines, and I don't want to discourage people from doing that entirely, because I think there are going to be some great game jam games that do come out of Unity and Unreal code bases, that find how you can melt those down and make Legos. Find the little modular pieces that you can pull out of them that are fun to tinker with, and that are fun to explore with. Because I think a lot of really cool discoveries come out of exploration. And tip number 3, when you encounter resistance or new inspiration, let it move you to try new things. I think part of the flow of a game jam, especially given the extreme time pressure, it can be tempting to think that you have to be very goal-oriented and plan everything up front. You're going to have some brainstorming session with your team on Friday, come up with an idea and you'll want to get to work immediately and start cranking out assets and moving towards that goal. But I think the idea that you came up with on your Friday night brainstorm, maybe it's a good idea, probably it's a perfectly fine idea. You might come up with some better ones, though. It's not precious, and I think you should be willing to ditch it if it's hard, or if you think of something better. That's totally fine. So those are my tips. From here on, I want to hopefully put my money where my mouth is and show you how we can apply some of these in a game jam-like context. So I'm going to be sharing my Pico 8 screen. We're going to do some live coding, and you can see already my error that I had from running this code earlier, but let me clear my screen here. This is not meant to be a Pico 8 tutorial, so I'm going to go over some of this quite fast. And I also hope that most of what I show you here is fairly transferable knowledge, that even if you're not using Pico 8, maybe some of the ideas that I share with you today, or that you come up with while you're watching me, are things that you can use in your own favorite engine. So, if you have never heard of Pico 8, it's a, fantasy console. It looks like an old Famicom NES kind of thing, or an old retro computer. When it boots, you get a terminal, like this one, and you can run some command prompts, run some commands on the command line interface. If you press escape, you can come here to your tools, and I have some starter code that I wrote earlier that I'll be going over. We've also got tools for spriting, so I can show you some of the sprites I have here. These are some little tiles for making just a room, real basic room. I've got a corner wall, I've got a flat wall, I've got a centerpiece, I've got a tile map. So this is using all of the tiles from my sprite sheet. I can draw with them and fill in the tiles here like that. And something that I'm not really going to be using today is the music and sound effects, but they are available and built into Pico 8 as well. So I think that's really neat. On the coding front, there's a pretty small API, a pretty small framework that you gotta learn for Pico 8. It's really not that much, and I think that makes it very approachable. There are 3 framework hooks that you should know about. One is init. This is going to run code that runs once when we boot up the game. I've got underscore update. I actually have update 60 here, which is specifying that I want to run my update at 60 frames per second. And then I have a draw hook. So this is going to redraw the screen, again, 60 times a second. I've also got some different code tabs here. These are some vector math utilities that I'll be using. Probably your engine has these built in if you're not using Pico 8, but if you are using Pico 8, you'll have to write your own vectors, so that's something I have here. And last is where I want to be doing most of my live coding. So, first off, let me quickly go over the starter code. I've got a player, and I've got a camera. That's really it. In my update function, I'm going to read the inputs, see if you're pressing the left, right, up, or down buttons, and if so, I'm going to move the player. The thing that I want to focus on today is how we control the camera, because I think that's a really cool way to add some personality and polish to your games. It's one of those things that's very invisible, but once you start seeing it, you can't unsee it. And I think when you play like a platformer, if you play a Mario game or something, the camera does some really quite sophisticated things. It will try to, of course, follow the player, but also show where you're going to run towards, rather than just centering Mario right in the middle of the screen. And it also does some nice things to sort of steady out any jerky movements in your controls, or any, for example, if you're jumping, you don't want the screen to follow you vertically until you've landed. And that's actually a very important thing for platformers. So, the first thing I've got here, and this is part of our tip number 1, embrace constraints. In Pico 8, we have a cool function called camera. It will move the viewport, both left, right, and up and down, but that's it. It's not a 3D camera, it's a 2D camera. It won't scale in or out, and it doesn't rotate. So those are all constraints that we have to work with. What our camera controller code is going to be doing is just figuring out where to position this thing, and that's all we have to do. If you remember Game Jam tip number 2, it's when life gives you nurdles, make Legos. And so that's where I want to spend some of our coding time, because I think one of the drawbacks of Pico 8 is that anything that you want your game to do, you have to code in Lua, and it sort of feels like you got a Lego kit with a million pieces in it instead of just a few dozen or a few hundred. So we're going to start building some building blocks that we can use to make cool things in a hopefully exploratory and fun way. Oh goodness. Yes, Katie and Eric want to know how many bunnies are going to be in this game. I don't think I have any bunnies in this starter code, but I do have some bunnies that I want to show you later in the demos. There will be at least one bunny. Alright. Yes, so I want to talk about how we can control this camera. And another constraint that I've given myself is I want our camera follow to be this function that we call. I'm going to give it 2 parameters. I'm going to give it the old camera position, and I'm going to give it the player position, or the target position where we want it to look. And that's it. And that function has to come up with a new position for the camera. And that's what we'll have going on this tab over here. I have 2 parameters. I'm calling them C and T. It's camera position and the target position. We need to return a new position. There are a few things that come to mind here. We've got 2 positions. We need to return 1 position. One way we can do that, just return the first one. That's easy. Now I should be able to run this code, and you can see I can move around my character, and the camera doesn't move at all. It always keeps its old position. So that's maybe not super useful yet, but I think it's a valid building block. So I want to save that for later, and I'm going to give it a name. We'll say that's follow fixed, because it's just returning a fixed position, and that'll be our function here. There's another thing we could do. I'll say something like that for now. So you can see this camera follow, which is what we're calling here in our update function. That's going to be this function. I said we had two positions as a parameter, and we have to return 1, so what's the other obvious thing to do? Return the other one. And that one I'm going to call follow track, because it does track the player. And we'll do it like that. So we'll show you what follow track looks like. Here it is tracking the player. And kind of unfortunately, if you have the camera follow the player directly, it doesn't center the player, it puts the player in the upper left corner. So that's not so great, but we can make our next building block. And I want to call that one follow offset. This one's going to be a little bit different. I'm going to make a function that returns a function, because I like functional programming and I think it's a cool way to make stuff that's modular. And that looks a little like this. Inside my function, I'm going to give it an offset parameter. I have to return a follow function, so that's going to look like these other ones where I have a C parameter and a T parameter. And what we're going to do is we're going to return T plus an offset. So now I can use this follow offset function, and I will give it an offset of 64, 64, because that's half the screen width and half the screen height. And one other thing, if I remember right, I think I actually want to subtract here. If I did that right, we now have the player in the center of the screen. Alright. So far so good on the live coding. Right, I have two other thoughts in mind for some really small primitive building blocks kinds of things here. Like I said, we can return parameter 1, we can return parameter 2. What's another thing we can do? We can combine them. We can do something with both of them. And I think that's where this interface, where this coding, I don't know what to call this. This coding gosh, I'm totally blanking on the word I want to say here. That's all right. Anyway, I think when we start combining these things is when we start getting some really cool results. So this one I'm going to call follow smooth. Is this a very, yeah, Zach asks, is this a very functional style of coding? It is. One of the things that I like about functional styles of coding is that functions are very remixable. You can combine them in interesting ways, and I'll be showing a couple of those ways later. It's what I think makes this, for me anyway, feel very exploratory, feels very like tinkering with Legos. It, I think, does take a little bit takes a little bit of getting used to this coding style, and so, you know, if it's something that doesn't come naturally to you, then find something that does. I think I'm not showing this to say this is how you should code your game jam. I'm saying this is an option for how you can code your game jam. Alright, I gave away one of the punchlines a little bit early here. I'm calling this follow smooth, but you'll see why hopefully in a second. I've got two positions and I want to combine them somehow. What's one way to do that? It's to average them. So I want half of the sum. We'll add them together and multiply by half. So I can show you what follow smooth looks like. And I don't have my offset, so I'm back here in the corner. But what you can hopefully see, if the stream frame rate is high enough, is that the camera, it kind of lags behind the player for just a little bit, and eventually catches up. And right now that effect is quite subtle. One thing we can do to make it more pronounced, though, is we can change this factor here. So right now I'm taking the exact middle, exact average. What we could instead do is introduce a smoothness parameter. So we'll say, I'm going to call this fac for factor. Since I'm returning a function here, I don't need to give it a name anymore. But we'll say follow smooth fac, and I want to do a linear interpolation here, a lerp. And so what we'll do is we'll add C plus fac times the vector that goes from one position to the other one. That's what it looks like. And now I need to give this a smoothness parameter, so we can try giving this a really small one. Give it like a 1/10 or 1/100th even. That might be a little bit too smooth, but yeah, you see this camera is now kind of smoothly following. It eventually catches up to the player, but it gets closer by tinier and tinier increments every time. So that's a kind of cool effect, I think. And one more building block before we start doing some compositions. And that is, I said there are a couple of obvious things that come to mind. One is return parameter 1, one is return parameter 2, one is combine them. What's the last one? Return neither! Ignore them both! And that we'll say is called follow stationary. We're going to make the camera just stay on one position. I'll give it a position as an input here. And this is going to return a follow function here again. And this follow function is not going to return anything to do with the camera or the player position, it's just going to return a new position. And so I'll make an example of that. We'll do camera follow equals follow stationary. I need to pass this a vector. We'll give it, let's say, 128 on the x-axis and 64 on the y. So there it is. Our player kind of starts off screen, but they eventually can find their way to being on camera again. Right. So far we've seen a couple of different follow strategies, but they've all been very isolated. They're not Lego bricks yet. We're not making big things out of small things yet. And I mentioned this is one of the things that I really enjoy about functional programming. So I can say, if I have a couple of follow functions and I want to put them together somehow, we'll say they're f and g, because that's what the mathematicians would call them. And once again, I want to return some new camera follow function here. Then a thing that I can do is run my first function, f. I'll give it those parameters. And then I want to run the second function. If these were just one parameter functions, this is the way I would write it. And since this has two parameters, I need to make a decision about how these combine. And the one I want to go with, and honestly, I think in the spirit of being exploratory here, let's just try them both and see what they do. Right? I could give you the answer I came up with already, but sometimes instead of justifying what I'm doing, I think the thing to do is let's just do it and find out. So we could call it like this, or we could call it like this. These are the two sort of obvious things that come to my mind anyway. And maybe I'll write this a little bit long form for now, just so it's less parentheses and less sort of code noise of what we're doing here. So I'm calling f first, and that is something that I know for sure that I want to do when I'm doing this composition. I want the first parameter that I give here to be the function that gets called first. And then the second one I can call either like this. We can give the original camera position and then pass in that new value that came from our first function. Or I could flip it, and I could do something like this. And then we need some things to combine. We need some examples here. And I think the ones that I want to show you first, I definitely know I want to use this offset thing, because I think without it, we end up having the player follow in the corner, and it's kind of weird. They kind of look like they're off screen, so let's call our compose function, and the first parameter, or one of the parameters anyway, will be our offset function. And again, I'm going to give it the half width and half height of the screen. And I can give this another parameter. So we can do maybe offset and smooth. And let's do 0.2 or something. So we'll see what that looks like. And that's alright. I think we have something new that we didn't have before, but the result didn't end up with my player in the center quite like I'd hoped, right? So let's try the other one. See if that gives us something we like. We can call it, we'll call our second function with the original camera position, but the updated target. And I think this is a lot more what I had in mind. I had thought, you know, here are two little tiny Lego bricks that I made, and here's a way I can stick the two of them together and get something that's both novel and useful. One more thing on the topic of composition is that I think being able to glue two pieces together is great, but being able to glue a whole bunch of pieces together all at once is a lot more useful from kind of a tinkering perspective. It's more ergonomic to write the code that way. So I have a chain function in mind that's going to take a bunch of a whole table, a whole list of these little parameters, and I want to loop through all of them and run them in order. So I can show you. We need a thing that we're going to start with. I'll call that ret because it's what we're going to return in the end. I want to start with this track function, this one that just takes in the target and returns the target, because that's kind of, to me, that's like not doing anything. You're just passing along the data you got in as input. And that's one of the properties we want for this. We want, if I give you an empty table, say combine all of these 0 elements, then I still want that to give me something meaningful. I said I wanted to loop through all of these, so this is the way to do that in Lua, or a way to do that in Lua anyway. I can use this for in syntax, or in do, and that's going to be for in all elements of table. I want to make this I want to chain together this function using this compose, using this little piece of functional glue, and we'll pass in the old function and the new function. Again, if you're not very used to functional programming, some of this looks really arbitrary. Where are you getting this stuff from, Matt? I don't understand. If you are used to functional programming, this all looks very straightforward to you, hopefully. I don't know. It's sort of hard to gauge exactly where and how much detail I want to go into here, but for now I want to move on and show a couple of different things. Do feel free to ask questions in the chat. So I now have this chain function. I can call it like this. We'll give it a table. And if I have even more things I want to put in here, we can do that. I think some of these won't give very interesting or meaningful results. Like if I make one of these things in the loop a stationary camera, that one's just going to take precedence, and all of the other things will kind of go away. But we can chain together the smooth camera and the track camera like I've done, or with the offset camera. What else can we do? I think I maybe need some more building blocks. So I want to talk through another one. This is something that I was inspired by some of the other Pico 8 games that I've played. And I'll talk a little bit about why. I think it's really kind of distracting if you have the camera moving a whole lot. And when I put in this smoothing factor, it's a little bit less bad, but if I sort of turn off the smooth, you can see if I move the player back and forth really fast, I have this really erratic, kind of shaky back and forth camera thing. And I think that's distracting. I think that's sometimes a bad gameplay experience. But one of the things that we can do is we can sort of add this dead zone. So like, if the player moves just a little bit, you don't move the camera. They're still somewhere generally in the center of the screen, and you don't have to move. And if the player moves a lot, then you sort of make the camera catch up to them and recenter the player. And with vector math, there's a pretty cool way to write that. It's something I'll call follow steady, and we'll give that a radius as a parameter. Let's see. The first thing I want to do is I want to get this vector that how far away is the player from the camera. I'll compute that. So we'll calculate t minus c. If the length of that vector is smaller than the radius, then we don't move. We just turn the camera position. That's going to be what we do to steady that out. Otherwise, we want to compute how much to move it by. How much do we need to move to get the player back in the center? And that is, we want to come up with this distance. This is the distance we have to move by. The length of that vector minus the radius. Then I'm going to add that direction vector back to the current camera position, and we'll use that distance to scale it. So I can show you what that looks like. I'm going to turn off the smooth. Hey, I don't know if that stream is caught up yet. Does everyone still see me? Can you still see my code? My video's frozen. Okay, well, I can deal with that. Can you still hear me and see the code, at least? Code's moving. How's the sound? Someone say something in the chat if you can still hear my voice. Oh, good, you can hear. Okay. Hey, alright, well, I'll turn off the camera for now. We'll maybe see if turning it off and back on again works. Nah. Alright, we'll continue without the camera for now. That's been sort of a theme in some of our live streams recently, but... right, I was going to show you what it looks like when we use this steady function. So we'll give it a, I don't know, say 10 pixels radius. And as long as I'm hanging out here in this center part of the screen, if I don't move too far away, the camera doesn't move. I can make these erratic movements as the player, and it doesn't cause motion sickness, hopefully. But as soon as I move outside of the center of the screen, then the camera moves to keep me in the frame. So that's that steady function. I can combine all three of these. We can have a smooth camera and also apply this steady function to it. And when I do it in that order, it's kind of interesting. It looks like that dead zone got a lot bigger. So I wonder, can we try it in a different order? We'll do the smoothing at the end, and that keeps the player a little closer to the center. I kind of like that. Yeah, now the dead zone's a little smaller when we do the steady first and then the smooth. So, and that's what I was kind of saying about this chain operator. I like that I can really easily come in here and, you know, either just comment out a line and skip that part entirely, or I can, you know, copy, cut and paste, reorder these, come up with new combinations pretty quickly. Let's see. Yeah, there's another thing that I haven't gone over yet, or I haven't really shown yet, but I think it's kind of interesting, and I think maybe we should play with it a little here. I gave this one a factor, and this smooth function a factor, and it's something I'm using to do this linear interpolation. And it kind of makes sense if you're used to how linear interpolation works, that I would want that factor to be somewhere between 0 and 1. Right? If I make it 0, it's always going to return C, and if I make it 1, then it's always going to return T, and if I put it somewhere in the middle, it'll pick one of the midpoints, or somewhere in between them.
Amy, can we just reload the guest star thing just real quick? Yeah. Let's see.
Try it again with camera.
Nope.
Still no camera.
Okay.
I'm going to put it back on screen share. Hopefully my screen's back. Okay. Right, I wanted to talk about this this smooth thing, because I think having this factor be in the 0 to 1 range is kind of what makes sense, but you know, it doesn't have to be. We could make this 1.2 and just sort of see what that does. I think in this case I can't really tell what that's doing. It looks about the same. Let's maybe just for now isolate that, so we're just doing, we'll keep the offset, but yeah. Yeah, that's kind of interesting. It's got a little bit of a new behavior to it, where, you know, while I'm moving the player and then I stop, I get this little screen shake thing. So I don't really know if that's super useful in this way. Maybe we could make it, you know, some bigger number even. Then we get real shaky. I don't know if the stream likes to show you how shaky this is. It's very shaky on my screen, and I think it looks a little bit shaky on the stream. But in any case, we end up with this thing where we kind of overshoot the player, and then we go back the other way, and I don't know. I think it's kind of an interesting result. I don't know if I want to use it in that sense, but I think it's a really good inspiration for some other things we can do. And one of the things that I've seen some other games do is camera shake. I think that can be really add some panache when you shake the camera if the player falls and takes damage, or if there's a big explosion on screen or something like that. So let's write a follow shake. Excuse me, I don't want to return a function here. I want to return something. What are we going to return? We're going to return our target plus something. Plus, I'll call it v for now. I want to come up with some offset vector, and I want this to be random. I want to use my rand function. And even more than that, we'll scale this by some shake factor. So this could be something. Right now, I'm just going to make it a global. We're prototyping. This is Pico 8. I think it's okay to do stuff like this. It's not something you want to ship in your production code, but it's Game Jam approved. We can have our shake factor. And what else? I want this randomness to be sometimes positive and sometimes negative. So I'm going to subtract. Let's subtract 0.5. And that's going to give us something in the negative 1/2 to positive 1/2 range. And if we want it to be in the negative 1 to positive 1 range, we can double it. So we'll do that. And now I can have this shaky camera, add this extra bit of something. Oh, it's a little hard to look at. Gotta turn that off. Alright. How are we doing on time, by the way? We've been at this for about an hour. That's not too bad. I think from here I want to show some of the results that I played around with earlier. So I'm gonna let's go ahead and save this. This is my demo, and I've got a couple of other things I can show you here. One is I wanted to sort of illustrate the point of what some of these things are doing. You know, here's my fixed camera. Doesn't matter where the player is, doesn't matter where the camera originally was, it just always is there. If we track the player directly, the camera's always going to be where the player was. If the camera's stationary, it's just always going to be there. But here's some of the more interesting ones. This is what that smooth camera is doing under the hood. It's giving us that in-between point. Or here's what that steady thing is doing. You can sort of see how it interacts with the dead zone. And as soon as I move inside there, the camera doesn't move anymore. And as soon as I go outside, it comes to track towards the player. Ooh, that reminds me. Yes, this is another one I wanted to. Another building block I wanted to go over is. It's pretty useful, I think, to have the camera stop moving when you reach the edge of the world, right? So I'll go back to the demo and we'll see. You know, like, I can just keep going off to the left until I'm in a sea of nothing and you can't even tell if the player's moving anymore. Let's fix that. Let's put in some boundaries. And I need some parameters for this, so we'll say we need an x min, what order do I want to use? We'll do x min, y min, x max, y max. So how far can you go in the x direction, how far can you go in the y direction? And I need to return a new vector. If I make a new vector like this, I'm just taking out the x component and the y component and putting them back in a new vector. That's not going to change anything, but this gives us a place to put some logic. So Pico 8 has a very handy function called mid. And mid takes 3 parameters, and it returns whichever one's the middle one. So if I give this an x min and an x max, we give us a ymin and a ymax, then this is going to return a value that's clamped, that ends up inside those bounds. And we'll set that here at the end, I think. Follow bounds. Let's see, we'll say 0, 0 is our minimum point in x and y, and our maximum is, I'm not really sure. We'll say 512, 512 for now. That'll be the size of our world. And now you can sort of see what this is doing. I get to the edge of the world, I can keep moving the player off to the side here, but the camera does not follow any further than that edge. But it'll follow me if I go further into the world until we hit the maximum part of the world. Eventually, there it is. And then our camera stops. And we'll do the same in this direction. I feel like I should know this off the top of my head, actually. How tall is the Pico 8 map? Because apparently it's less than 512 tall. But, let's see. Let's do a little math here. We got... our tile map here. It says y is 63 is the max on the y direction, so that'll be 64 times 8. And then I need to subtract one screen's worth out of that. So subtract 128. I think that's going to give me the right bounds here. Hey, look at that. Okay. So we got a whole bunch of pieces. We can combine them in. We have a couple of ways to combine them. I want to jump over to a file that I worked on earlier that's, I think, showing off some of the range of things you can do with these different building blocks for camera stuff. So that's my file called cam. And I've given the rooms different colors, because I'm going to be going through some different rooms, and each room has a different camera behavior. I'll show the code for that later, but first I want to sort of show what that does. So we're starting off in this room where the camera doesn't move, doesn't follow us around. When we go over here, we get this nifty smooth transition. And we can sort of go screen by screen. I had this thought, like, I don't know, what if we had some world that we're going through and we get on either a moving vehicle or like we get in the elevator or something and the camera's really shaky, but just for that part. So here we are on the shaky elevator until we get off, and now we're back in some calmer part where I've got this kind of this steady effect going on here where the camera's got that dead zone applied to it again. And then I thought, you know, I sort of glossed over it earlier, that stationary camera. It was something that we wrote just sort of for completeness, but I think when you have those ideas and you decide to give them a try, keep that code around for a little while. Maybe you'll find a use for it later. So I thought maybe in this other room the camera's stationary, but when you get there it's going to show off this cool dinosaur, and I want the player to focus on that, and I want that to be this big moment in the game where the camera pans up to show you this whatever cool piece of art that you worked on, and you know, it sort of stays there until you leave the room and goes back to tracking the player. So those are some of the things I came up with while I was playing with this code earlier. And of course I promised I would show you what that looks like in code, so let's do that. I have a couple of rooms that I find here. They're just a x0, x1, y0, y1. And I have a function to decide if you're in a room or not, because we're going to use that to decide which camera behavior to apply. And so I've got all my follow strategies over here. We've got that smooth one that I showed earlier. We got that stationary one that I talked about. We've got our offset and our steady and all these things, right? And I also had this thought. It's this sort of dynamic dispatch camera. So I give it this function. I called it cam here. I don't know. I should maybe think of a better name for this one, something more descriptive. But we'll pass in the two arguments, and this function is sort of responsible for deciding what do we dispatch to. And that's sort of how we can use it here. I've got this dynamic thing where we'll check if the player is in room 1, and if so, we'll return this room 1 behavior. And if they're in room 2, maybe we have this different behavior, and if we're in room 3, we use the shaky elevator camera. If we're in room 4, I think I called this camera battle, because I was thinking, if you're in some... the player has to fight off a bunch of enemies, and they're coming left and right, and you have to turn around really fast. And that's kind of one of the reasons I think you'd really want this dead zone, this kind of steady cam effect. So that's what that one's doing. I showed off this, hey, look at the statue, and like I said before, that one's actually just built out of this stationary thing that I didn't know if we'd have a use for originally, but I thought of one, and so there it is. But where I think this exercise in making these camera behaviors really shines, what I think is kind of the really cool part about doing this exploratory coding, rather than downloading some platformer camera controller asset off of the Unity store or something like that. And you can do that, and it would save you some time. And if you knew you were making a platformer, it's not necessarily a bad thing to do. But we ended up with something, I think, a lot richer than that, because I've been talking about making the camera follow the player, but really I just have a function for making a thing follow a thing. And I got to thinking, what else could we have? We could have some little ducklings that follow around the mama duck. And they follow each other in this chain of ducks. And maybe this is more compelling than coming up with a cool camera controller. Maybe I want to make a game idea around this train of ducks now. It could be kind of neat. I like how the last duck in the line, it kind of follows a much smoother path than the one the mama duck does, right? So if we had some obstacle course or something where you needed to navigate your duck babies around the mud puddles so that the little one doesn't step in the mud, maybe you can make a game out of that. I don't know. Or I got to thinking, what if we use these different follow behaviors to give characters a personality, right? So I've got this husky dog that follows the human around pretty closely. I guess they sort of stay in the lead here. But I have this other one, this sort of smooth one where the player can kind of get ahead a little bit, and the Chihuahua, it kind of needs a while to catch up. And maybe I use that shaky effect because it's a little Chihuahua and it vibrates all the time or something. I don't know. I think it's kind of cute. So, we can use these building blocks that we created to do other cool game stuff. I can create the camera behavior, but I can also create some kind of cool behaviors for the characters in the game. Like I said, the husky, it follows pretty close to where the player is. It's using this sort of smooth effect, but with a pretty big number, comparatively. And, if we make this number really small here in the smooth factor, then, the Chihuahua takes longer and longer to catch up. You just give him a second. Eventually he'll get there. Maybe I made it too small. You coming? You coming, buddy? Is he coming? I don't know. We'll do something like that. 1/10 or 1/100th, not a 1,000th. One more idea that I had earlier today while I was prepping for this, but I never actually tried it out. So this is truly the live coding experience here. I did talk a little about what happens when we make that smooth factor like bigger than 1, right? We end up with this kind of shaky result. But what if we make it smaller than 0? Now I have a thing that instead of walking towards the player, runs away from the player. Oh, he just really takes off there. Let's make that small, maybe 1/10 or something. And this reminds me, and I think I need to draw this. This reminds me that my mother-in-law used to have a dog that was a very fast greyhound, and that happened to us a little bit. If you kept a tight leash on her, she would stick with you for a while. But if that dog had the chance to run away, boy, could she run! So maybe this will be my little homage to Opal the greyhound. Let's see, make something that looks vaguely dog-like. Here will be my greyhound. And we'll do a little sense of depth here. How's that? That's okay for pixel art. Alright. So I want to make one more dog here. That'll be greyhound, and we'll make them start off close to where the player is. Maybe they'll be real tight leash. They're just a couple of pixels away to begin with. And then I need to update their position. So say greyhound equals greyhound follow. They are going to follow the player, and we're going to use their old position as the starting point. So what else can we do? We can draw their sprite. That's going to be sprite number 9 on our sprite sheet. And I need to give them X and Y coordinates and width and height in sprite sheet tiles. So they're two tiles wide. And I think maybe that's it. Oh, I need to actually define this follow function. I haven't done that one yet, so let's do that. I'll put my Chihuahua back to, I don't know, 1/20th or something. And let's do, I'll just copy that Chihuahua behavior over here. We'll say their offset is just 0. They follow the player real close, if you let them. And if you let them run away, they're going to run real fast in the other direction. Up to the bounds of the map. I'll turn off the shake for them, though. So there's my greyhound. If we let them get off leash, are they going to run for it? Oh, my greyhound's not running. Why is that? Can we debug here? The other thing I want to do, I want to make that noticeable, easier to see. Okay. Maybe my steady parameters here are getting in the way of what I want to do. called it something different. Alright, anyone in the chat want to help me debug this? I haven't quite figured out what's going wrong. Yeah, something does seem like it's not hooked up. Wonder what it is. Alright, one thing. I need a better tail. There's the tail. Alright, that's my running greyhound. It's also got to be thinner. That looks more like a greyhound. So, what did we do? We have this follow function. We're getting the old greyhound. Greyhound is not how you spell greyhound. That might do it. Oh, there they go. They're gonna run away from me. Woo. That's kind of fun. Let's see that one again. Come back, come back.
Catch it.
Alright.
There he goes.
There he goes. So that's my that's my exploratory Pico 8 coding. Let's see, do I have other things that I wanted to show off here? Yeah, I think that's pretty much a wrap for the demo, so. Alright. I do hope that I've inspired you to take a little bit more of an exploratory mindset towards your game jamming. And hopefully you can find some of the techniques here useful. Maybe you'll give them a try in your games. If not, at least the mindset or the, I don't know, the experience of playing with your code. And I think that's all the slides and all the talk that I have, but I'm happy to take any questions if you have them in the chat. Otherwise, I'll pass it back over to Josiah. Josiah, you're live.
Yeah, sorry, just waiting to see if we have any questions.
Yes. Of course, of course.
Okay, well, I'll go ahead and say thanks, Matt, so much for sharing everything. That was illuminating. It's great to see, how all those little pieces fit together and how you can take a bunch of little bits and build them up into something that's really cohesive and helpful. So that was great.
Thanks. Yeah, I think that's a really good... I don't know, I've been saying this a lot, but I just think that's a really cool way to do creative things, is try a couple of small things and figure out how you can make bigger things out of them.
Well, we have one question. Did you write a custom type for the vector type?
I can show you my vector code, yes. If you take a look here at... I'll load my starter code again. This is in my first tab. There's... and I didn't want to spend too much time on this initially because it is very Lua specific, but if you are somebody who is using Lua or Pico 8, then I think this is a really great technique to know, or a great thing about Lua to know that you can do. That is, you can define these add, sub, and mul operators using metatables. And if you define those, then Lua will let you use the built-in plus, times, etc., and subtract functions just like if you were working with regular numbers. So that's how I'm doing the vectors. I can, by the way, I will make all of this code available, so if you'd like to study it further, it will be up on GitHub and on the Discord. So, just going over this real quick, like I said, here's this mul operator, and I'm using that to call the scale function, which is something I've defined on the vector type. So scale is doing this, multiplying the components of the vector by a scalar. And you can use this set metatable command to make the objects that you create with this v2 syntax into vectors that you can add and multiply and do all the cool vector stuff with. Good question, by the way.
If there are no more questions, maybe we'll wrap up.
Great.
では、マットさん、発表していただいてありがとうございます。
Hey.
So, I would say, I would give the date for the next mentor session, but this was our last mentor session tonight, and the game jam will be starting this Friday. I think it starts at 6 p.m., or that's at least when doors open at the site. Or sorry, doors might be open a little bit before that. I will confirm that.
Oh gosh, I am very remiss, and while I'm screen sharing, I did promise at least one bunny, so...
Please do that.
Yeah, one of the projects I got going in Pico 8 is this bunny that can run around and jump, and this was, I think, initially part of the inspiration for this talk, actually. I wanted to try to take apart and understand how platformer cameras work. And so how this one works is there are two follow functions. One of them is following the spot where the bunny is going to be, and the other one is making the camera track that spot. So you can see while I'm running to the left, the bunny's on the right side of the screen, and when I'm running to the right, the bunny's on the left side of the screen, and it sort of gives you a little bit better understanding of which part of the level is coming up next. And I think, if I remember right, bonus detail, if you fall from a really high height, I did put in the camera shake. So there it is. There's
That's a
some
great
bunnies, and there's some platformer camera stuff that I want to share with you.
So, thanks for that. that is a great bunny.
Thank you very much.
Just to confirm, so registration, is from 5:30 p.m. to 6:30 p.m. This Friday. A keynote starts at 6:30, so we'll want everybody to get registered in before then. As a reminder, we have the Ko-fi that we're using to support purchasing for snacks and drinks and other amenities during the game jam. So anything you could contribute really helps us. 日本語で、また、コファイのリンクを通して応援していただければ嬉しいです。本当にボランティアで自己負担で、頑張っていますので、お願いします。Hi, I guess that's all from me. I just want to say thank you everyone for participating. 皆さん参加して一体で本当にありがとうございました。And we are looking forward to seeing you all in person at the site on Friday.
All right. I'll see everyone at the game jam.
Have a great night, everybody.
Yes. Good night.